Point out that in this, we get the mean of the sample proportion will be whatever that row is. So if I was talking about lefties, I'm talking about right here in the middle, it's that 13%. Or that 0.13. But these will be decimals. Alright, so that will be smack dab in the middle of the bell shape. Whatever that is. Whatever that proportion for the population is. That goes in the middle. And then we can look at the same probability questions, but this is the mean, or excuse me, let me change that, I apologize. When this is the standard deviation, I just caught that, I apologize. That's that lowercase sigma. It equals that rho value times 1 minus rho over n. Cool. All right. Hey, the checks for this problem. If the distribution was skewed, remember we said the sample size had to be greater than or equal to 30? Everyone, for this problem, the checks are, in order for us to do this, we got to make sure that n times p, n times rho times 1 minus rho has to be greater than or equal to 10. And n must be less than or equal to 5% of big N. These are our checks. We're going to make sure when we work the problem that this comes out true. Alright? Now, let me go through this. We're just going to take the sample size, multiply it to the population proportion, 1 minus. We'll make sure it's greater than or equal to 10. That means we can work the problem. That means the sample size is big enough for us to work the problem. We didn't deal with the sample size too small. And that way it's absolutely normally distributed. This, don't let this bug you too much, everyone, but I did put an uppercase N here. That's the sample size. This is the size of the what? The population. This, a lot of times, everyone, big N, a lot of times is in the millions. It's huge. If they don't tell you what big N is in the problem, it's okay for you to assume it's like at least 1 million. Okay? Notice though, you're not going to enter a big N in here. We're just going to do it for the checks. Alright? Now, does everyone have a copy of those checks? Cool. So you'll have that. I'll make sure before you leave today, you go, I didn't get a copy of that. I'll make sure to hand it to anyone as you leave the room today. Alright, let's get to a question. So I'm going to go to your textbook. This is from 8.2. This is not bad at all. This is on page 418. And I'm going to do number 11. And they say this. A simple random sample of 75 of size 75 is obtained from a population whose size is big N equals 10,000. So don't be surprised when most of the problems, they don't give you big N, uppercase N. We can assume it's in the millions if they don't give it to us on some of these problems. It depends though. And whose population proportion is rho equals 0.8. And when they put a 0 before that decimal point, just to emphasize there's a decimal point there, so I'm going to do it too. Hey, write it like that. 0.8, which is 0.8. Notice there's no hat on this. So that's that population proportion, okay? All right. I'm going to keep this up here for a little while. There's the check. It's almost like you can call this the requirement for us to work the math. You go, what do you mean? So that the population that we're dealing with, it's approximately normal. Is the distribution of the sample proportion approximately normal? It is, as long as these hold true. Okay, so the first thing I'm going to ask is that question. All right? The author writes describe. I find that vague, so I like to do yes, no. You know, yes, no question. So let's just title this letter A. Yes or no? Is the distribution of p hat of a sample proportion, we haven't gotten one yet, but is the distribution of p hat approximately normal? Question mark. We're going to write yes or no, then we'll talk about why. And when this is our why, we're going to justify it with this. That right there. So when it comes to this question, is the distribution of, this is the sample proportion. Is it approximately normal? Is it bell-shaped? Is it not skewed? It is. With these proportions, sample proportions, as long as this holds true. Cool. We're just making sure that sample size is big enough. You know, we're not dealing with like 3 people. Or remember with the lefties, everyone? There's like 25 people in here. I don't think we'd be able to do the math with that. But I could do it with like 100 people. That's what I'm pointing out. So, let's go through here, and I'm going to check n times this. You can call it p, it's really rho, isn't it? N times rho times 1 minus rho, and how high does it have to be? It's got to be 10 or higher, right? All right. So in this case, when I'm doing this math, and when they said, where's the sample size? Look at all these numbers. That's big N. That's rho. There it is. What's this?
75.
There it is. And there's the sample size. That's N. So feel free to go up here and go, oh, you're N. And if you have to go off to the side, you can list these. You're like, listen, I've got N equal to 75. I've got this rho that equals 0.8. But I've got a gigantic N that equals 10,000. And we're going to do all these checks right here. We're just going to check that. Okay. Hey, don't get confused between these two. This was not the requirement for this. This had a simple requirement. If the distribution was like skewed or we had no knowledge of the distribution, the sample size here on the requirement, n just had to be greater than or equal to what?
20. 30.
30. Yeah, 20 would probably be okay, Art. We're just really conservative. We're like, make sure it's a sample size greater than or equal to 30. That's if you had no knowledge about the distribution, whatever we've done. That's if the distribution was skewed. That last problem I did, remember the pregnancies? Remember I did 20? We didn't need this because we already knew about that distribution. Gestation period, we're like, that's normally distributed, so we're fine. All right, let's just check all this math. What's this? 75. What's this?
0.8.
0.8. What's 1 minus 0.8?
0.2.
All right, is that 10 or higher? Is that greater than or equal to 10?
12, yep.
Is that higher than 10? 12, all right, this is 12, we're good. Hey, before I write yes, I'm going to check this too. So when we're good here, check, it's 12. Hey, you all are pretty smart. On the test, don't you think it's going to be higher than 10? Because if it wasn't higher than 10, could you work the math? Do you agree? You would say, nope, it's 9, I can't do this math problem. Sorry, turn in your test, right? You follow me. So we're just making sure. But I think it's important to discuss because a good example would be, remember me talking about lefties? I bet you everyone, the population, I think about 13% of lefties, people in the world are left-handed. I think with our sample size here at 25, we couldn't work the math. We can look at the probability this way. Of saying, what's the chances we could have like, 10 out of 25 be lefties? Hey, what's this other part? N has to be greater than or equal to what? N has to be less than or equal to 5% of this. This just accounts for bias. It's funny, everyone, if you're like, what does this mean? We just want to make sure that we didn't get too big of a sample size. We're not sampling like hundreds of thousands of people. That's all. So when this sample size right here, or I'm even like 1,000, is n less than or equal to 0.05 then? This was 75. Is 75 lower than or equal to 5% of, what's big N? 10,000. So when I'm taking 75 and just making sure it's lower than or equal to 5% of 10,000.
500.
That's fine. And so is 75 less than or equal to 500?
Yes.
Oh yeah, way lower. So we're good. So put a big yes here. Here's our y when we showed our checks. Also, you could write down it's a random sample. That's key. You want to include that because that's important too. When it comes to our requirements, let's make sure it's a random sample. Let's make sure it's a random sample and we go through that. Hey, don't let this bug you. Even I'll be honest, even stat teachers get tired of doing this because it slows you down. You want to work the probability question. I'm serious. You go, oh gosh, we got to do these requirements. We got to check our requirements, right? So don't let that really just annoy you. It's just we're going to go through the checks and just make sure we're good to go. This means the sample distribution is approximately normal and we can use all this stuff. It is roughly bell-shaped.
So is that what you look for on the test, or can we just put it in this random sample?
Great question. For me, on my test, you could just write yes, right? And then here, how about you just write this? You don't have to put those numbers down. Just write that and that. And you know, it's like, oh, should I memorize that? It's going to be on that attached sheet anyway. It's so important for us, we're like, we just want students to be aware of this, that we can't just go out and get a sample size of 10 and work this question and look at the probability this way, right? It's like there is some limit to how many people we should get at least in our sample. So, but are you okay with that? Yes, and then you're like that and that. And then here you could just say yes, and if you didn't know anything about the distribution, you can just say, hey, my sample size is going to equal to 30. I do like when you include though it's a random sample. I think that's wonderful.
In the check, when you get that over here, where did the 0.2 come from?
That 0.2, great question. So in this formula here, I'm going through here, that was the 75, this was the 0.8, they were both given to us. Look at the next part. It says 1 minus the row. So Brianna, what I had to do is take 1, now you could type it that way, parentheses 1 minus 0.8, but we did it off to the side just to see what it was. We're like, what is this? What's this 1 minus? So we took 1, we subtracted the 0.8, which gave us the 0.2, and that's where it came from. Hey, if this helps, Brianna, we see 1 minus p a lot in the class, and in this case it's a 1 minus rho. So a lot of times I just write this whole formula right here as
Q.
Yeah. A lot of other textbooks do the same thing. Q comes after P in the alphabet. This looks like a P, right? So we just go MPQ,
So,
if that helps. But the Q is always the complement. You can just take out the calculator and go, what's 1 minus that last proportion there?
so like when you do a population, you read it as NPQ, and when you do sample, N row Q.
There you go. And row Q.
N row Q.
And they look like P's. And we call it looks like that's a row. Awesome. And row, 1 minus row. We're still calling it Q though.
Q.
All right, and it's an easier remembering. I go, n's greater than or equal to 30. NPQ or N row Q has to be higher than a 10. That too, this just makes sure we didn't get too many. Sometimes when you sample like too many people, you can get bias. That's what we're saying here. If you get too many people, that population. All right, everyone, we're now going to go on to a question. All right. What's the probability of obtaining 62 or more individuals with this characteristic? I'm going to write that down. What is the probability of obtaining 63 or more from the, remember the sample size was 75? With this characteristic. The book writes characteristic. You can ignore this wording right here, but what's key is 63 or more from the
75.
75. And I'll wait till you all copy that. And then when I know this stuff's in the book, but I like to get this on the board, and I like when you get it in your notes, because it is about keywords and what we do, so we don't make these little errors. Right now, you and I are going to do something really important. We haven't seen this before. You and I have to write something important down. Everyone see right here? Hidden in all those words is a p hat. In all those words, hidden in this sentence right here, is a p hat. So let me go run over here. What's p hat again?
X over n.
X over n. So when they write this, they're explaining a p hat. And I want you every time to go off to the side and be like, I'm going to write this down on my own. What is the p hat? They didn't give this to me. You know? What is it? And I'm looking at this. Remember, the denominator is always the biggest. So it's always x over n. Well, this is a 75 for this problem, right? That number is the what?
63.
63. This is a decimal, and I would get the decimal
0.8.
right away.
0.84.
That's the key. It's the only thing we got to be careful with this section. We can always look at when they ask the question about the probability, we're like, well, what's the p hat? Is it
84.
0.84? So I'm going to write this down, Evan. So you know what we're looking at for letter B? Here's the question. What's the probability p hat is greater than or equal to a 0.84? That's what we're looking at. That's the question we're trying to answer. And there's a bell. And when I'm going to draw a bell, step one, we still do 3 steps. Step one, here's the bell-shaped curve. Before, in 8.1, the middle was at 266. Well, do you know who's in the middle of this thing? The row, the population proportion. That's always dead center, the mean. Right? So what was the row, the
Point-
P, looks like a P.
0.8.
This is right in the middle. The 0.8 is right